Question here. This is our position versus time. So this is the distance versus time, position versus time, however you want to think of it. Um, and I'm going to ask questions that are very similar to the ones that were from your homework. So from this graph, can anybody tell me where are the two places? And I just gave you a big hint. Where are the two places where this person wasn't moving? You can shout them out. B and E. So in B, the person's not moving. They're stuck at 5 meters. And at E, the person's not moving. They're actually back at the starting line. All right. Who can tell me where the person was walking away? So which of those are you walking away from the starting line? So yeah, so I mean, like, if this is a starting line and this is my runner, he's walking, this would be walking away, this would be walking towards. So where is he walking away from the starting line? Where is he going forward? I'm sorry, A and F, and there's one more. Did someone say C? Yeah. So, yep, so it's A, it's C, and it's F. So in all those places, this person is walking further from the starting line. And then there's one place where he's walking back towards the starting line. That would be D. That's right. So D right here, he's walking backwards. He's walking back to where he started. All right, now where on this graph is this person moving with a constant velocity other than 0? So where is he moving with constant velocity? Okay, so other than 0. So E it is, but right, but it's 0. Okay, so A and C. There's one other place too, though. And D. So anywhere on this graph where there's a straight line, he's walking with constant velocity. Okay, so then where on this graph would he be accelerating? F, that's right. So if you can answer all of those questions, like, you're in good shape. And then remember that from this graph, there's one thing that we can mathematically calculate, and that is the actual velocity by taking the slope, right? So slope here is velocity. All right, so let's go to our next graph. Okay. Oop, that's the same one. So let's go to our next one. And actually, I am going to, I thought that I had refreshed this. I'm going to delete all of this stuff out of here. Where's my eraser? So I'll start with a clean slate here. So remember that on this graph, the slope is the acceleration, because that's change in v over t. And then the area under the graph, that would be the distance that the object has moved. Okay? So on this graph, where does the object, where is it moving at a constant velocity other than 0? A, B, C, D, E, or F. So where's it moving at a constant velocity other than 0? Yep, B. So B, right here, the velocity is not changing. It's constant. So that spot, that's 0 acceleration. So if I had asked, that's another thing I could have asked, where is the object not accelerating and still moving? B is the only spot. So I just answered this question. Where would the object be accelerating then? Either positive or negative. AC. And yeah, no, E and F are right. Yeah, you shouldn't second guess yourself. So A, C, E, and F. Now, it's accelerating in each one of those places because the velocity is changing, right? And then there's one spot where it's not moving, and that's D. D, it has zero velocity, so 0 meters per second. Now, where on this graph is the object speeding up? There's two places. Yep. Oh, nope, I'm sorry. You're half right. So A, it's definitely speeding up. So 0 to 5 to 10 meters per second. But F, F is slowing down, right? Because you're going from like -5 to 0. So E is where you're speeding up. And then if I ask, I'm sorry, you're going, say that again? Yep, yeah, that's right. Exactly. You're going in reverse. So here, I'm accelerating, cruise control, and then here I'm slowing down. I come to a stop, I reverse, speed up, and then I'm still in reverse, but I come to another stop. So if you could answer all those questions, once again, we're in pretty good shape. And then we'll go to our very last graph. Sorry about this. Once again, I'll delete all this stuff. Okay. So this is kind of a trick question that I'm going to ask. But where on this graph is the object not moving? So, yeah, so where does it have a velocity of 0? And I know that a lot of you were thinking 10 to 15, all right? So if you thought that, don't be embarrassed. Don't be upset with yourself. But from 10 to 15, it's actually moving, all right? The only place that it could not be moving, the only place that it could be at rest, and we don't know for sure whether it is or not, is at the origin. So at time 0, this object may be at rest, but there's actually no way for us to know that, okay? The only thing that we do know is that at time 0, it's accelerating at 5 meters per second per second. So at the end of this 10 seconds, can anybody actually tell me how fast it's going right there during this stretch? So it's accelerating at 5 meters per second, right? We'll assume that it started at 0. So it's accelerating at 5 meters per second for 10 seconds. So after 1 second, it would be going 5 meters per second. After 2 seconds, it would be going 10. After 10 seconds, it would be going 50. That's right. So after 10 seconds, it would be going 50. For this stretch right here, it's going at a constant speed. It'll be going 50. So, so if I asked where this object was stopped, the answer is it can only be stopped at the origin. It's the only place, right? Because here, it's accelerating, it's going faster. Cruise control, it's accelerating here, it's going faster. Here, it's decelerating. So then if I asked you where is the only place it's slowing down, I kind of just already told you. It's between what and what? 20 and 25, because that's the only place that it has negative acceleration. So positive acceleration means it's going faster. It's going faster. Negative acceleration means it's going slower. And the only way that this would stop is if I added up this area and I added up this area and it was equal to this area. So if the speeding up was as much as the slowing down, then you know the final speed would have been 0. But I think we did this yesterday and it wasn't. It was still going pretty fast. Yeah. No, okay, so from the origin to 10, it's getting 5 meters per second faster every second. So if we were to draw this as a v versus t graph, I'm I'm going to do kind of my pathetic version. Okay, so this is what it would look like on a v versus t graph. Because it is accelerating, the velocity would be increasing the whole time until it got to 10, and the velocity here at 10 would be 50 meters per second. Then from 10 to 15 on the v versus t graph, it would go flat because the velocity right here is not changing, the acceleration is 0, and so the velocity would stay flat here. And then, right, it's constantly increasing. So from 25 to 30, the exact same thing is happening. So on my v versus t graph, this would be from 0 to 10. This would be from 10 to 15. Let's say this is 15 to 20. It's speeding up. Then from 20 to 25, it's slowing down. And then I stop slowing down. My acceleration goes back to 0. And I continue at a constant speed. So I have my cruise control on again. So if I were to take this acceleration versus time graph and make it a velocity versus time graph, the velocity versus time graph would look like that. Does that make sense? Okay. So today for these little quizzes that you guys are going to do, they ask a lot of questions like that. So it'll ask you to compare the graphs. It'll ask you to think about it. And if you get them wrong, it just gives you another question that's very similar to that. Yeah. It'll always be that way because remember I told you that we're only going to deal in this class with constant acceleration. So the acceleration is not going to change. If the acceleration was doing this, then this velocity graph would look very different, and finding the area under those curves and the equations that we would use would change, right? We could do that with calculus, but I don't want you guys to have to worry about calculus right now, right? So yeah, so for this class, only constant acceleration. So it'll always look like these rectangles, right? Because the acceleration will always stick at one number, and then it'll jump to the next number. So it was 5, then it becomes 0. Then it's 10. So you're punching the gas, and you go from punching the gas to pumping your brake. So it's either 10 or it's -5, right? It's not, it won't be anything in between for us. Now you guys know that in real life doesn't work like that, right? So this is going to be pretend physics world, where we're making our lives easier for us. And then if you guys, like I said, if you guys pursue a science career, if you pursue an engineering career, then you get to talk about acceleration graphs that aren't all like squares and rectangles, but we're not going to do that in this class yet. So does that make sense to everybody? Yeah? Okay. Hold on one second.